Okay, we've looked at spreadsheets, now let's look at databases, which can also be used to both process and present data. Processing meaning changing the data in some way, making information basically, and presenting meaning sharing the data. So, databases are primarily used to store basically any type of data, with maybe the exception of objects. Objects being a discrete component like a table or graph can't really be stored in a database, mostly because databases are tables, but numbers, text can be stored. So really, database is designed to store, not necessarily designed for processing and presenting, although you can use them for that purpose. Right, as I say, and as you may know if you've done LO5, we generally have at least one or more tables in traditional databases at least, and so this is a table, right? This is of cartoon characters. We've got different columns, different fields, and the rows are called records. And in a big database, this is a separate one, there are lots of different tables related to each other via relationships. So we've got a customers table here is related to the orders table, which is related to the staffs table, and so on. So different tables connected via relationships. Not necessarily relevant here, it's just a quick recap or a quick overview. We're interested in how they can be used to first of all process data. So there are not loads of reasons, not loads of examples honestly, because they're mostly for storing data, but they can sort data, for example. So in a table, often, so this is access, you can click on one of our column headings to sort it. So sorting it maybe alphabetically, as it is in this case. So the A's come first, from the B's and so on. Numerically, so the lowest number to the highest number, or vice versa, and maybe according to the dates, so the oldest to newest. That sorting is processing, right? The computer's doing it for us, doing some processing on our table, and we can have it in ascending order, going from small to big, or descending, big to small. We can also do validation in databases. So validation is making sure the data being stored is appropriate, so meets our criteria. So for example, if we're storing a password, which requires quite a lot of security consideration, if we're storing a password, we need to make sure maybe that it is a certain length. So conducting a length check is a type of validation, making sure it's longer than 8 characters, maybe, if that is your criteria. That is processing. We're checking the input to make sure it is acceptable. And like in spreadsheets, if we are doing some repeated task in our database software, we can record a macro, and the macro will record that task, and we can play the macro whenever we want to redo the task instead of us doing it every single time. That is going to help us to automate our processing and generally speed things up. And now let's look at how we can present information. Remember, data is processed information. So we can search in databases, called querying. So searching data to only show what is relevant to your situation, right? So if only one thing's relevant, you can set up a query. This is a cross-tab query. Effectively a search. We can look for certain columns, maybe certain items of data, and we can reduce our tables being shown to just a result from our query. So if we're only interested in, say, one table or one person, we can set up a query and it will return only that subset of the data we had originally. This makes it easier to present. This is processing again, really, because we're searching, but the actual presentation makes it a lot more relevant to our situation because it can be massively reduced. Most database software can also take the result of a query to generate a report. So a report is usually there to summarize your information. So we might have a query to extract a certain table. A report can be generated to summarize it. Now this makes it easier to view any key information. This is quite a fancy report. Often it's just another table which is just summarized a little bit. This one's got a chart and also maybe the result of a query shown in this report. I can maybe print off this report, show it to my colleagues. It makes it a lot easier to view the key information as opposed to the entire database, which may be massive. So you can, in lots of database management software, have some tables created from tables, a bit like spreadsheet software, but it's not really the key purpose, although a nice chart is useful for presenting your information. Okay, let's evaluate database software as a method then. So they can store a large amount of data that's really valuable, not quite big data we covered in LO3, because big data is sort of hard to manage, is the whole point, but a large amount of data which is obviously useful, although it can make processing a little bit hard. Another advantage is queries and reports can be generated, can be used to present only relevant information. You've got loads of data stored maybe, but only some of it is relevant to your particular task at the moment. You can use queries and reports to narrow it down and make it more relevant, which is good. And other processing steps like validation can prevent errors. So validation about checking inputs. If you don't check it, you might have some error introduced. Maybe your password is too short. We want to make sure it's valid, and validation can do that. However, as you may have experienced, actually creating the database and organising your tables and so on, organising the different relationships, can be quite complex and does require some understanding, which you would have to learn somehow by a teacher or by some training. So training may also be required to use the more advanced features. You can't just walk in like spreadsheets and suddenly master all of the fairly complicated relationships and queries and reports. It requires some learning, which is not good for someone who is a novice to databases.